Hello, everyone. Hello, hello. Um, so glad you could join me today, this evening. All right. Where are we all tuning in from? I am currently based out of Texas in the US. Hello, hello. I know we have people from all over the world. So just drop wherever you're from in the comments. MD Maryland? Okay, we have some more people from Texas. All right, all right. Hello. New York, India, okay. We got a diverse crowd. Okay, very US heavy, but we have one person from India. I love that. Awesome. We're just gonna wait maybe a couple more minutes to let a few more people like file in. But in the meantime, just really quickly, what we're going to be going over today in the stream is just how to build a blockchain, right? Um, Blockchain or like crypto, and that whole world is very confusing. I found it very confusing. I'm sure some of you all may have as well. And I found the best way to actually learn something is by building it, right? I've built other things before in order to help me learn things. And I was like, okay, I want to learn about crypto. I want to learn about blockchain. Best way to do this is to actually build it. So I built it, and now I'm here to help you all build your own blockchain as well. All right. Hopefully, you all are excited. Do you all have any experience with blockchains, just by any chance? Just want to ask. Put that out there. Just put it in the chat. How familiar are you all with blockchains? What your level of comfort is? Have you maybe invested in some cryptocurrencies? Have you bought some NFTs maybe? Um, okay, we have a lot of zero. Some people know. Not at all. Okay, great, great. We have a good crowd. This is good then. I like this. Some, but not hands-on. Okay. Uh, Mooses, you said like meta. What do you mean by that? We have some people saying, okay, a lot of zero and no. So, okay, this is going to be a great opportunity to just dive into the world of blockchain and crypto and all of that, all those great stuff. So, we will get into it in a bit. And again, if you haven't already, please make sure to check in at this link right here. That way, you all get credit for attending. And yeah, okay. Just going to give it a couple more minutes for some people to join, and then we will dive right into it. Okay, so really quickly, just everything we're going to be going over today is just a brief overview of crypto and blockchain and all that crazy stuff, right? Then I'm going to demonstrate exactly what we're making. What is the app that we're actually creating? It's just a spoiler. It's going to be a lot of just API development. Unfortunately, right, blockchain isn't very front end or UI heavy, so there isn't a lot of like fancy front end work going on, but it's going to be really interesting to see how everything works in the back end and just how all of this logic is structured. So if you're really interested in things like security or even like the financial sector and all that crazy stuff, then I recommend you stay and actually build the blockchain till the end. It's going to be fun. All right. Um, so really quickly before we get started, if anyone has any questions, again, just feel free to put them in the chat. Um, I like the chat interface because there's like zero friction between myself and you all, right? If you have a question, just put it out there and I will do my best to answer it. Okay. So really quickly, just blockchains themselves are immutable and sequential chains of records. So these chains of records can contain basically anything, right? They can contain transactions, which is what cryptocurrencies have. They can have files. They can have basically any sort of data, right? But the important thing to remember about the blockchain is that each one of these blocks are chained together, and they're chained together using hashes. And hashes are basically just a way of uh, it's like a function which it makes it very deterministic function. Every input has a very specific output, and we'll be going into that in more detail later on. So if you don't fully get it, that's completely okay. Basically, what we're going to be doing today is going through how to actually build a blockchain. So we're going to be doing a lot of the development in Python. So if you do know how to write Python, that would help. If you don't, that's perfectly fine. You can always just follow along and just type what I type, right? Nothing wrong with that at all. And then if you do know how HTTP requests work, that will also be very helpful. If you don't understand that or you don't know that, that's also fully okay, right? We will be going over that because that is how we're going to be talking to our blockchain. So you will need a newer Python version, ideally something after Python like 3.7, 3.8. And then we are going to be using Flask and the request library. So um, basically the way it's going to be looking is, let me pull up my screen really quickly so you all can see what is going on here. Oh yeah, in the meantime, again, if you have any questions, then let me know. So, hi, how's the day? Asked what tools will be needed for the stream. If you have an IDE, that is ideal. An IDE is basically any sort of editor where you can edit any Python files. So the one I will be using is VS Code or Visual Studio Code. I recommend downloading that if you don't have it already. And then we will also be using, again, a lot of Python libraries in order to run our app. And let me think if we're using anything else. We will also be using Postman. Postman is basically a way to interact with APIs. Very useful, but if you don't want to use that, you can also use curl commands. That's completely fine. And Moose said the metaverse. This doesn't have much to do with the metaverse. It is, if you know anything about like Bitcoin or some of those meme cryptocurrencies like Dogecoin, that's sort of what this is. The fundamental technology that is behind those financial systems is the blockchain. So that's what we're going to be going over today, just how to build a very, very simple version of that and how it works. Do you need to download Postman? I would recommend it just because it will be easier to interact with the API as opposed to using curl commands in your terminal. I will personally be using Postman, but it is, again, completely up to you. I would recommend it though. So if you don't have it already, now's the time to get it. And then Devin Dark One said Ethereum, like, yes. So Ethereum is a cryptocurrency, and that is, again, built off of the blockchain. Now, really quickly, let me pull up this right here and start the server. Then I can actually share my screen. Hmm. I'm not seeing my screen up here. There we go. Okay. All right. So what we will be going over is just how to create various endpoints, and we're going to be using Flask for that. Essentially, the way that the code here is structured, I'm just going to make sure that is visible. Hmm. Okay, I was sharing a window and not the screen. There we go. There we go. Okay. So you saw over here that I have just this running locally, and it's currently just printing out a very simple message. Welcome to the blockchain API. What we're going to be doing is building this entire blockchain. You can see it's a lot of code, about 200 and almost 250 lines. And there's different API routes. Basically, we have different transactions, which is, you can see the type of method it is, if it's a post or a get method. And right now, let's just take a look at the chain. So if we go here, we can see our current chain. And again, like I mentioned, the blockchain is a sequence of records. So this is the current chain that we have. It looks like we have one trend or zero transactions that are in here as of right now. So we can actually post a transaction by going to the mine endpoint, and then we'll be mining a new block. So you can see that a new block has been forged. It actually gives the hash. We're going to be doing calculations for the hash, and then we get the proof, and then the actual transaction over here, who the recipient is and who the sender is. So this again is going to be sort of financially based, but again, this has applications for pretty much anything. All right. Any questions before we dive into this? Okay. Looking like no questions. Again, you can ask anything you want whenever you want. I will be keeping the chat open on the side in case something does come up. And I'll be going at pretty slow speed, but if you need me to slow down a bit, I can. If I'm going way too slow, please let me know, and I will adjust my speed accordingly. All right, let's get started then. So we actually do have a question from Priscilla. How do blockchain translate into crypto? So, okay, how does blockchain translate into crypto? Basically, the blockchain is the technology that's behind cryptocurrencies. Cryptocurrency, the key advantage of them over what people say is like, the traditional financial systems is that cryptocurrency has an immutable sequence of records. So you know exactly who had every or who owns crypto. And then that's, I think, one of the big pluses. Another one is that it's borderless, so you can use it from anywhere in the world. But the way that blockchain specifically translates into crypto is that that is the technology behind everything. And as we go through this demo, or as we build our own, we'll really do a deep dive into this and understand blockchain, how cryptos are built on top of blockchains. All right, so I'm going to be opening a file then, or opening up a new folder, and call this, let's do blockchain live, because we are live and we're building a blockchain. And we're going to open this up. So we currently have our blockchain live folder. And again, if you need me to slow down, please let me know. And I'm currently using Visual Studio Code for this. All right. So the first thing we're going to do is actually set up our file. So we're going to call our file blockchain.py. That did not type anything at all. Let me do that again. Blockchain.py. And this is going to be where we are doing the majority of our work. All right. Okay. So the first thing we're going to do is actually build our blockchain class. So let's do that. Class blockchain. And I'm going to be going through some of this really quickly. What I'll be doing is writing blocks of code and then explaining what's going on after that block of code is written. I'll try to do explanations as I'm writing as well. But if you do have a question that I did not answer, do put it in the chat and I will try my best to get to it. So right now we're going to be writing a blockchain class, and that's where everything's going to be taking place. We want to actually initialize our blockchain class as well. So we have the first thing we want is the chain. We'll get to that shortly. Let me write the init and self.chain. So this is going to be the actual chain that we're using for our blockchain. And we saw that earlier in the demo that I had up. And then we can also have the current transactions. So self.current transactions, and this will be set to a list. Then we also want a few functions. So what we need is, for like a very, very basic implementation, is at least the ability to create a new block, the ability to add a transaction to the full list of transactions. Then we also have the specific properties of each block, which is we're going to be having an initial block, a last block, and we're going to actually need a function to hash each block as well. All right. Make sure no one's saying anything in the stream. Okay. So let's start with our new block, and this will be pass in self and we're going to use the static method decorator specifically for our hash, because that is not going to be changing. Hash for each block. And then lastly, we have our actual last block. Last block and pass in itself and pass through this. And let's actually put a property decorator on this, because that is a property of the class. Property. Okay. So this right here is just a quick blueprint of the blockchain class. So the actual blockchain class that is over here is responsible for actually managing the chain. So it's going to have all the transactions, and we have some helper methods that we just added in order to add new blocks to each chain. So the way each block is going to look is it essentially has an index. So the number block that it is, it's going to have a timestamp, so we know exactly when the block was created. That way we're not dealing with inconsistencies with it in indexing it, right? And then we're going to have different transactions that are within that specific block, so different senders and recipients, in this case for a cryptocurrency. And then we're going to have a proof and a hash number that change, or that previous hash number. So a hash number that chains the current block to the one that was before it. And I have this. Let me bring this up here actually. Example block. That did not type anything. I'm not sure why it's doing that. Example block. And this is what an example block might look like. So it has the index, so what block number it is. We're starting at 1. The timestamp of the block specifically, the different transactions, and the sender and recipient IDs, the amount of whatever we're sending. Let's say this is MLH coin that we're sending, right? We're sending 5 MLH coin. And then this is the actual proof and the previous hash for the one that was before this. So you should understand now that this is how that this is sort of a chain, right? How this is where the chain in blockchain comes from. So each block, right, contains itself, and then it also has the hash of the previous block, and that's sort of where you're chaining all the blocks together. And that's sort of what is the key idea behind blockchains. It's what gives it its immutability. You're not able to really mess with much of the block because if you corrupted a block that was, say, at number 5, then you'd know immediately that, okay, number 6 through whatever till the end has an incorrect hash. So this cannot be a correct transaction list. Does that make sense? That's like a really important, I think, key behind it's a really key idea behind blockchains. So that should make sense. And if it doesn't, let me know. I'll do my best to explain further. Okay, I'm not seeing anything in the chat. Again, there's blocks, and they are all chained together using this specific hash. I just want to make sure you'll understand that key idea behind blockchains before we move on. And then again, each person who, let's say for crypto as an example, each person has like a full record. So each person has the entire list of transactions, the history, the hashes, and the next blocks. So if their version disagrees with another person's version, then we end up doing something to figure out whose version is correct, and then it sort of goes from there. So hi, how's the day said kind of like a mix of hash maps and linked lists. Similar, you can think of it like that for sure, yeah. But it is a little bit more to it, but if you boil it down to its components, yeah, it is essentially some hash maps and then linked lists. It's just you're not really trying to store data, or it's more just to identify the list of data. All right. Okay. Then moving forward, we can actually try and fill out some of these functions that we have. So let's add a transaction to the block next. So we have our new transactions method, and we can actually fill that out. It should be pretty straightforward. So for each new transaction, you're going to have a sender, you're going to have a recipient, hopefully I spelled that right. Yes, I did, let's go, and an amount. All right, so the amount that you're going to be sending. Did I mess this thing up? Okay, good. So for each transaction, you want to basically append these specific values. So let's say for self.current transactions dot append, and we're going to have a sender, a recipient, and a specified amount. And that'll close out. And then we want to return the last block. Oops, index +1. There we go. So basically after the new transaction method adds a transaction to the list, it's returning the index of the block where the transaction is being added. So this is basically the next one that will be mined. And this is essentially going to be more useful later on in the demo, where we're actually where to the user that's actually submitting the transaction. And let me make sure there's no questions. So we do have one question. So the hash chains them together. Yes, the hash is what actually determines which one is next. And we will be going over sort of how that works. Actually, we can do that right now. I think it might be useful. Let me keep this up for a couple or a few more seconds just so that everyone has the new transactions function, and then we can actually go over how the hash is going to work. Okay, so basically, the way that hashes themselves work is that it's supposed to be something where you can have like, uh, oh, that is not some input going in, and you always get the same exact output going out every single time. So that's essentially what the idea is behind hashes. So if I input this for a single hash, then this is going to go through some function, and there's a lot of different ways you can hash something, and then it will output the same exact number every time. Does that make sense? So you can honestly create any sort of hash. We in in like in blockchain specifically, like any blockchain, you're going to have a proof of work algorithm as well that really pushes this hash, and that's sort of how you are able to verify who's like who's solving a specific problem. And this is usually used in like Bitcoin and other sort of cryptocurrencies where there's actually the idea of mining something. And I think we might touch on that a bit more later on. But does that answer your question and sort of how the hashes are important specifically in this context? Okay, awesome. And again, if that's also not clear, you can always reach out to me after the stream. I'm more than happy to help. All right. Now that we have our new transactions complete over here, we are going to move on to actually adding our new block and figuring out what we're going to be doing if we have an original block, right? So new blocks are usually added after something is already there. But in order to add something, we need something to be there. And the word for the original block in a chain is called the genesis block. So we're going to be needing to add that constructor. And then we're also going to finish fleshing out these methods over here. So we can actually import a few more classes for this. So let's import hash lib, and this is for the hashing. Import JSON just to make it much easier to work with, and import time. And that's how we're going to be getting our timestamps. Okay, so we have our chain over here, and we have our current transactions, but we also need something for the new block. So for our Genesis, did I spell that right? Genesis block, we are basically going to have self.new block, and then we're just going to give it some parameters. So pre hash to 1, and we can set the proof to anything we want. And then for the actual new block, we just want to create a new block in the blockchain. For this, we want to pass in the proof and the previous hash. and self previous hash and proof. Okay. And in this case, we are actually going to be creating our block. So again, we have our index, timestamp, transactions, proof, and previous hash. And we're basically just going to be using that over here. I'm just going to copy this because it is easier and quicker. But wow, I failed copy pasting. And please paste. Okay, there we go. Wow, that got messed up. Can fix the formatting. Beautiful. Okay, so we have our index, and we just want to set that to the actual length of the chain, right? So that'd be length of self dot chain +1, because we are indexing from 1 instead of 0. Then we have our actual timestamp, which we can just set to the current time. Then we have our transactions over here, which we are not going to be using all this. We can just use self.current transactions, and that will give a list of all the transactions. So self.current transactions, giving a list of all the transactions. The proof, which we will be working on shortly, and we are passing that in. So we can just write this, and then previous hash is just going to be previous hash or the last one in the chain. So if it's the Genesis block, then we're going to be using the previous hash, which is 1. Otherwise, we're going to be using self.hash, and we're actually using this to hash the previous block. So self.chain at -1. So this is how you get the previous block of the chain. And then I'm missing a comma. Okay. And then once this is done, then you want to actually reset the list of current transactions. So self.current transactions is an empty list. And then you want to append all of this to the actual complete chain. So self.chain append to this specific, or append this specific block. And then we are returning the block. All right, and then we have our new transactions function over here, which is already completed. We don't need to do anything with that. And then for our static method for hash, we'll actually work on that shortly. And for last block, because it's just a property, all we want to do over here is return the self.chain at -1 to get the last block. All right, hopefully all of that made sense so far. Let me check if there are any questions currently. Okay, nice, no questions. It's like everyone's busy coding this up, that's good. And when you all are done with this, do let me know in the comments. That way I can move on to the next section, which is explaining sort of the proof of work algorithm and how things are sort of supposed to be mined, in quotes, quote unquote mined. How do you mine a Bitcoin or any sort of blockchain or any sort of crypto for that matter? Just give it a couple more, maybe another minute. For everyone to catch up. then we can move on. Okay, awesome. Got some people that are starting to finish up. That is great. Okay, in the meantime, I think I will just explain the proof of work algorithm, and then we can actually see implementation of it. So the way, or what is the proof of work algorithm? It is essentially how new blocks are created or how new blocks are mined on a specific chain. So the actual goal of this is to find a number that solves a problem. And this could be any problem at all. All we are trying to do is find a number that solves it, and it's essentially a race, right? The first person to find that number is the one who gets to or like is mined that coin. So it's essentially a reward for them is okay, you win one coin, congratulations, right? So the goal of the actual proof of work algorithm is to discover a number that solves a problem, and it really needs to be something that is difficult to compute, but really easy to verify, right? You want it to be an actual challenge, right? You don't want one person to easily compute everything, but you want it to be very easy to verify and that you don't have to do a lot of work in order to say, yes, this is the correct result. So let's look at a quick example to help to help understand that. And let me just make sure that everyone else is beginning to finish up here. Okay, I'm not seeing anyone else who said they were finished, but I think it is safe to move on. Okay, so as a really quick and easy example over here, you basically want some hash to do something. So in this case, we can actually implement an example of this in Python. So from hash import and then SHA-256, and we'll use this specific hashing algorithm, but honestly, you can use any that you want. And if we set a couple of variables, let's say x equals 5 and y equals 0, right? We don't know what y is yet. So basically, we want to do here is while SHA-256 of x. I'll explain what I'm doing in just a second. I'm sorry. Digest 1 is not equal to 0. Okay, I think that's correct. Then we want to increment y. And then if that does go through, then print the actual solution. So that would be y equals, and then whatever y equals y. Okay. So essentially what we're trying to do here is find a hash, right? So we're hashing some x times y. The way this would work is you have like some hash. In this case, we're using the SHA-256 hashing, hash x times y equals, and then you're going to end up with some random string of numbers and letters here, right? So this is just an example. Obviously, this isn't an actual hash. Well, maybe it is. But what you're trying to do here is just verify, okay, is the last digit in this thing equal to 0? If it is, then, or if it is not, then we're incrementing y. If it is, then we're printing, okay, this is the correct value, right? Basically, in this one, if we didn't get 0, right, then this thing's going to increment by 1, and then we're going to try encoding this one more time. We're going to encode this, so x times, instead of 0, we're doing x times 1, and then checking if that equals 0. If not, and then if it is, then this hash might change to something else, and then if not, then we're going to do that over and over again until we get it so that this thing equals 0. So we can actually take a look at that working. Let me try and run this in my terminal. Python app.py. Oh, it's main.py. Oh. Python 3. Hex digest. Did I spell that right? Encode. Oh, it's not encoded. This closes out here. This closes out here. This thing is completely unnecessary. Okay, let's clear out my embarrassment. All right, there we go. So, okay, we see in this case that it took 21 tries for this thing to actually work. And essentially just to increase complexity, you just want to add more and more strings to the end of this. And they can be different strings. You can change it around as needed. But let's say we added another 0. Now we need to verify that the last two digits instead of just 1 digit is equal to 0. So if we run that again, then we can see it takes a lot longer to actually calculate. And hopefully this thing does not crash my laptop because it is thinking through this. Okay, wait, there's a logic error in here. That was dumb. Okay, so what this is doing is actually checking if the second to last one is equal to 0, 0, which will never happen because it's reading one character at a time. But in this case, if the second to last one was equal to 0, then it only took 8 tries. We can do a simple and over here. So and then just copy this entire thing. And let's say equal to 0 for the last digit. So this is if both the last and second to last digit is equal to 0 or not equal to 0, then you want to increment. And then if it actually completes successfully, then it will output the correct answer. So if we run this again, do not save this. Okay, we still get y equals 8. Let's try and change this. Huh, there's definitely an issue in here somewhere. Let's do a little more digging. But any questions on the basic algorithm here? Okay, I'm just ripping this off of my previous implementation of this. So essentially what's going on here is it's checking for 3 digits. So if this is not equal to z or this is not equal to z, then it's going to increment. So let's change this to okay, it was just an or. So this is essentially what the proof of work algorithm is. So if you understand how Bitcoin works, is it has this proof algorithm called hash cache, and it works in a similar way as this, or a lot of them work in a similar way as this. And you might have heard of like some Bitcoin mining, right? People try to mine Bitcoin, and the best way to mine Bitcoins is with these massive rigs that are really complex, require a ton of GPUs and compute power, and everyone talks about how unfriendly they are to the environment. Essentially, what they're trying to do is race to be the ones to calculate or decrypt or decode sort of this. So what are these numbers, right? We already know that x equals 5, but what number is y? We don't know what y is yet, and that's what they're trying to figure out. Okay, what is y? This is a really, really, simple version of that because I'm trying to not crash my laptop and I don't have hundreds of thousands of dollars worth of GPU equipment, unfortunately. But If I run this, then you can see that it takes significantly longer and a lot more tries to get to um, the correct solution. Does that make sense? Okay, there we go. Gosh. Okay. So let's say we wanted to check for 0, 0, right? How many tries will it take to get to a full 0, 0? Okay, so this is the solution right here, right? The solution we got was 254 tries. And then you can see that it ends in 0, 0, and that's sort of it. It took 254 iterations. You can essentially increase the complexity by increasing the number of digits that it's checking for. And that's just a very simple example of how it might work. Okay. Again, I just also put in the hash over here as well, so you can see exactly what the hash is. And I think that makes it slightly easier to visualize, hopefully. And again, we can chain more and more over here, and you'll see that it just gets more and more complex. So if we actually print out what y is as we're getting it, we can see that in just this right here, it took 21 tries. And then if we undo that right there and actually keep all those, it'll take the 254 tries. If we add another one of these so that we're checking for a third 0, you'll see that this actually increases exponentially. So this is, I'm gonna kill this process before it crashes my laptop, but you can see how many, oh, it didn't crash my laptop. It only took 4,043 tries, right? And then it found this specific hash right here. So that's essentially the core design principle behind how cryptocurrencies work. All right. So hopefully that made sense. Again, if it didn't make a whole lot of sense, uh, reach out to me afterwards. I will do my best to explain it better. But we do need to move on with our blockchain implementation. And I understand it's almost been an hour now, so I will give you all a little chance to rest, so a little break. And if you all want, we will, or actually, yeah, we will reconvene in about 10 minutes or 8 minutes. So for me, it's 7 p.m. on the dot. For you, that might be a little different. And again, if you have any other questions, feel free to ask in the chat, and then I will get back to them after the break. All right. And in the meantime, I will put this up so that you all can, or actually, yeah, I'll put this up so y'all can take a look at this, maybe experiment and play around with this on your own machines, see how many tries you can actually get to printing before you know, your CPU can't handle it or your GPU can't handle it. And yeah, we'll get back soon. All right. We're getting started in just under a minute. We'll just wait for a few more people to file in, and then we will keep going. So there's a question in the chat. To my understanding, a block can hold multiple transactions, and each are added sequentially. At what point do you start adding transactions to a new block? A block can hold multiple transactions, and each are added sequentially. Yeah, so actually, if we take a look at the example block, you can see for each one of these example blocks, these are going to be the full list of transactions between different people. So it could be between like myself and yourself. Oh, let me turn the music off. I forgot that was going in the background. Okay, there we go. Sorry about that. So essentially, the way it works is you add on new blocks for each unique time stamp or unique index. And we'll get into that in a bit later. But right now, the transactions for here per block are based off of each index, and that's for each person. And you have a proof for that and a previous hash. And then once that's complete, then you have a new block added to it. So a block can hold multiple transactions, and the transaction is going to be, let's say, multiple sends and receives at like one time, essentially. And then those are the ones that are added sequentially. The blocks themselves are also added sequentially. That's why they have a timestamp that is attached to them. And that's for a unique transaction. So you can do, let's say, multiple transactions at once, and that's what this is going to happen. And then if you are doing a completely separate one, then you'll add on a new block into the chain. Does that sort of make sense? All right. So there may be one or more transactions happening at once that go on a block, and each block is based on the time it was added. Yeah, exactly. And that's why I think the timestamp is very important as well for each block. So you know exactly when something is happening. And you can, like, if something happens within like a millisecond, then you're able to figure out, okay, this one happened first, this one happened afterwards. And that's sort of what the timestamp here is. Obviously, this is a very simple implementation. Normally, it would be a lot more complicated than like just this, right? You'd have a much more accurate timestamp for to actually figure out when each transaction took place. But yes, you can have multiple transactions at one time that are being executed at once, and then you can have, like, if there's a different transaction, then it's going to be added to the block separately. Awesome. All right, let's move on with actually building our blockchain. So we looked into the proof of work algorithm and how that sort of works. And in Bitcoin, actually, the way that it's worked, or the way that it's called hash cash, and it's actually not too different from what we actually built over here, right? It's basically an algorithm that, again, the different miners, they race to solve. That's why, like, the more expensive and the more higher end your rig, usually the faster you're able to solve this, because you're able to go through a lot more calculations at once. Sometimes you can go through them in parallel. You're trying to essentially solve this specific problem, and the solution to this is very easy to verify, right? So the network is really easy, can very easily verify that their solution is the correct solution, and then if they have that correct solution, then they are rewarded with 1 Bitcoin, and that is worth a lot of money now. All right, so let's implement something similar to this in our actual blockchain. So we have our hashlib JSON time, and let's actually import UUID. So from UUID import UUID4. Then we have our entire blockchain class here, and then we actually want to create our proof of work algorithm. So let's do that. Proof of work. And in this, we're going to be passing in self and the last proof in our chain. So basically what we're going to be doing here is finding a number so that the hash of the number times the previous number has 4 leading zeros. So let's do that really quick. We'll do current proof is set to 0, and then while we're gonna be writing a valid proof method as well. So while valid proof for last proof and proof. Is false. So while this method is returning false, then we can increment our proof value. One, and then let's return proof. And then we're going to actually have our valid proof method, which is actually guessing the proof. So we can fill that out as well. Valid proof. And we're going to have the last proof being passed in. And the proof, we don't need to pass self because this is a static method. Okay, good. So again, this is just validating it, and we're seeing does it contain 4 leading zeros? So we can go with our current guess is going to be the previous proof, right? So last proof and the current proof. Current proof. Oh my goodness, proof. And we're going to be encoding this value, dot encode. So this is what our guess is. And then our hash is going to be, oh, I can't use that. Let's say guess hash is going to be hash lib dot 256 guess, and we are going to hex digest and then return whether or not there are 4 leading zeros. So guess hash from everything to 4 equals 4 leading zeros. And then again, if we wanted to adjust the difficulty of the algorithm, we could just modify the number of leading zeros, but this should be more than enough. Again, if we added another one, it would take significantly longer, as we saw in our example, which the remains are still in the terminal. Actually, yeah, no, we don't have time for that. I was gonna up the number to 5 leading zeros and see how that was going to work, but let's focus. Okay, let me see if there's any other questions. Okay, it looks like everyone is on track. I love that. All right, so we're almost finished with actually creating this. Let's see, we have our last block. We have our hash. I did not complete the hash method. Let's complete that really quick. So we're getting the block passed into the hash. So basically what we want to do here is create a SHA-256 hash of each block. So we'll have block string is based on the dumps of the block, and we want to make sure the keys are all sorted so that it's true, and encode. Then actually return this. I almost return this, so return hash dot SHA-256 of the block string dot hex digest. Okay, so this is just for our actual hashing method. This is how we're going to be hashing each block. All right, so again, we worked on this right now, which was actually just hashing each block. So that just takes the full JSON dump because it's technically in JSON format. Just to make it easier, we have all the keys sorted, and we encoded this. Did not encode it, encoded it now. And then we're basically returning the SHA-256 hashing. That's just a hashing algorithm of the entire block string and storing it. Okay, hopefully that made sense so far. Let me make sure no one is confused. Did I add anything to the top of the code? No, so as of right now, I just imported the UUID for format. We're going to be using that, and then we have our Genesis block, which was added afterwards, and then we have our new block, which we created, and what to do if we have a Genesis block. Then for each new transaction, we're basically returning the index of where the next transaction is going to be. And then we have our hashing method, we have our previous block, we have our proof of work algorithm over here, and what actually validates the proof of work algorithm. So that's a quick rundown of what we've done so far. Next up, we're going to work on the actual API calls. So this is going to be the fun part where we can actually see things being done. All right. So let's dive right into it. So we're going to be creating three methods to actually test the blockchain. So it's going to be a new transaction endpoint to actually create a new transaction. We're going to have a mining endpoint, so we can tell our server to actually mine a new block for us. Then we're going to have a chain endpoint, and that's going to return the entire chain, so we can actually see what's happening. All right, so we're going to be using Flask for this because we are creating API endpoints and we're doing HTTP requests. So Flask is just a really easy to use framework that basically enables you to write web apps using Python. So we're going to just import Flask. Let's do that. Import capital F Flask. All right. And again, if anyone has any questions, do let me know. Nothing else at the top of the code. We have all this. Okay. Now we're actually going to be working on our Flask APIs. So for that, we're going to, first of all, actually initialize our node. So we can do that by doing app equals Flask with name. Yes. All right. And then we are going to have a unique address for this specific node. So node identifier is going to be a string of UUID4 and replace dot replace each dash with a blank space. Okay. This is basically to make it easier to parse and work with our node identifiers here. So then we can actually instantiate the blockchain. So let's say blockchain equals blockchain class. And then we are going to actually create the different app routes here now. So our first app route is app.root, and this will be for the mining endpoint. And this is going to be a getter function. So we can make that clear. Methods equals get. Okay. And then for mining, is that mine, and then we'll get to this. So this is just going to be for actually mining a new block. Then we have another route. I'm just going to copy paste this to save us some time. And this will be the transactions endpoint. So, oh my goodness, there we go. Transactions. Here, and it's going to be a post method. And then we are going to same thing one last time for our actual chain. And this is going to be get, and this is going to be the full chain. And in this case, we want the actual chain to be returned, so we can do that really quick. So response is going to be our actual chain and the length of the chain. So we can make that clear. That would do it. Okay. Blockchain dot chain, and then we are also going to have the length of the chain be the chain length. And then return a JSON-ified response with a 200 message. All right, and then if name then we want to actually run the app. So at our home port, and actually port can be set to, I'm going to use 8001, but you can use whatever you want. All right, this is the initial version of our Flask app. Any questions so far? again, we're going to get to a lot of this, but again, we're creating a Flask app here. And over here, we're just making the node identifier easier to use by replacing any dashes that are going to be visible in the UUID into just empty strings. So we're just replacing them with nothing. We're removing them. And then we're actually initializing our blockchain class here. And we're setting our different app routes. So our different API endpoints. So we have a mining endpoint, transactions endpoint, and a chain endpoint. Is that clear so far? Is there anything that I'm missing? Anything I can touch over in more detail? Do let me know. And then because we're using JSONify, we can actually import that. So from Flask, import Flask, we can import JSONify, and then we're going to be using a requests feature as well for HTTP requests. And then we're also going to be, just for cleanliness sake, using text wrap. So from text wrap, import ddent. Okay, there we go. Am I good to move on? Getting an error from the Flask app. So you do need to install everything. That would be, let's see what the command is for that. It should be somewhere here. If I scroll up far enough, okay, right here. So actually creating a virtual environment, you can either create a virtual environment or you can use your global. I recommend creating a virtual environment. This is the command that I'm using, Python 3.11-m virtual environment, and then the virtual environment name is going to be .venv. So this is going to actually initialize the virtual environment, and you can see there's a .venv folder over here. Now, in order to actually activate the virtual environment, you need to type in like source and then put in the directory. So on a Mac, that's going to be source.venv/bin/activate. For Windows, I know the command is slightly different. I think it's like pi activate or something of that sort. I recommend you search up how to either do that, or I know ChatGPT is pretty good at that as well. And then we can just set that to the source. And then you can see that the virtual environment has, we're in the virtual environment now. So we can actually install everything that we need to. So pip install, we have Flask. So we have request and Flask, JSONify, request. We don't need commas. Okay. Could not. Interesting. So we did install pip install Flask. Try this one at a time. Okay, there we go. And then I guess if that doesn't work, just do it. Requests. Okay, there we go. Yeah, just do it one at a time if that doesn't work, and then that should get the job done. All right. Any other questions before we move on? I know we are starting to get shorter on time, so take one more look. Yeah, so if you are getting an error, just make sure everything is installed properly, and then we really can't run anything. Like we won't be able to see much, but we can actually run this. So let's go with Python blockchain.py, and then it opens up our dev server. And we can see that over here, we're going to get a 404 because there's nothing at the specific endpoint. If you go to like mine, for example, which is where we're going to be going soon, once we actually write the logic for it, then you'll see that right now it's not a 404, it's a server error because we haven't done anything yet for it, right? So it says there's an error in the application because it was unable to complete the request, which is the case right now. So we will actually just kill the app for now. And then let's write our methods. So for each new transaction, what we want to do is, let's see. We're going to first check that all the required fields are in the data. So because this is a post method, so we're going to see, okay, do we have the sender? Do we have the recipient? Do we have the amount that's going to the recipient? And then if that's not there, then we're going to return an error because we want to do some level of validation, right? And then if all of that is there, then we're actually going to create a new transaction because the transaction does exist. And then we're going to give a valid response. We're going to say, hey, congratulations, the transaction actually did complete, and it'll be added to this specific block. So let's do that. So we can go with values and grab the current values equals requests dot get JSON for that. And then we want to actually check that the required fields are in the data. So required is the sender, recipient, and amount. Sender, recipient, and amount. Then if not all, then we can return that's missing some values, and let's throw an error response with it, 400. So we can save that. I think that's correct. Missing values, comma 400. And yeah. Then we also need to create a new transaction, right? If this does go through. So let's do that. Index, actually add comments so it's easier. New transaction. So we have our index, which is the blockchain dot new transaction. And then we're adding the value sender and recipient. Sender, comma, values, recipient, comma, values, amount. Okay. And then if this does successfully execute, then we just want to return a approve response. So let's let the user know that it's working. Response equals, in this case, the message. Message. And then here we can just add the index of the block that it will be added to. And then we want to return the response. So, and a 201 to indicate that was a successful operation. And then just for my own sanity, I normally like to pip install black, and black is basically a tool for code formatting, so I can just go like blockchain.py, and then it will format this entire thing for me. It'll look much better, and it's more readable for you all. Okay. This is what we have so far. Oh, great. Let's overwrite this and do this again. There we go. Okay, now it's cleaned everything up. So you can see that everything looks a lot nicer now. This is our transactions method. It's all on, or none of it's going way out of the off the page. Okay. So this was for creating a transactions. Now let's work on the actual mining endpoint. So this is where actually most of the magic is going to happen, right? Basically, this needs to do three things. It needs to, first of all, calculate the proof of work, then reward the person who's mining, which is going to be us in this case, by adding a transaction and giving us like 1 coin, maybe, for example, and then actually creating that new block and adding it to the chain. All right. So in this case, let's make sure we have everything we need and then start mining. Before this, let me just make sure there are no more questions in the StreamYard. And hi, how's the day? Were you able to get your Flask app up and running? No. Do you know what the error that you're getting is? You can just paste it into the chat. And was everyone else able to get it working? There's a squiggly under blockchain. Is your blockchain in the correct place? Because this needs to be, again, this is no indentation off of the end. It might have auto indented so that it's like under the blockchain class itself, but you want to make sure that the class over here is completely separate. So your class is going to be, in my case, from lines 11 through 62, and then the app.flask is going to be directly underneath. So just make sure that there's no indentation on anything underneath app equals Flask name, and that should give you, or that should solve your problem. And let me know if it does. Also, let me know if it doesn't, and then we can also look into it a little bit more. But we do need to move on. So let's go into actually creating our mining endpoint. All right, so for mining, we're going to, again, proof of work algorithm, then receiving a reward for finding that specific proof, and then we can forge a new block. So let's do that really quick. So proof of work algorithm, and that's going to be the last block set equal to the last block in the chain. And last proof equal to the last proof in the chain. So our current last block's proof value, then the proof is going to be set to the blockchain dot proof of work algorithm, and actually see our last proof. Okay, there we go. So this is, again, just running our proof of work algorithm, making sure everything works using the last proof. Okay, and then we want to also receive a reward. So reward the miner for finding the proof. Ooh. Okay, so again, we're going to set the blockchain new transaction to the sender, in this case, to be 0, because we're going to signify that this node specifically mined a new coin. So there isn't going to be any specific sender in this case, right? It's just going to be 0. And then the recipient in this case is going to be the node identifier, and that's what we're using to actually identify different people. And then the actual amount we are granting them is 1 to combat inflation and all that good stuff. We can, again, we can grant them more. We can give them 10. We can give them 100. Again, it's fully up to you. You can customize your chain however you want. That's what's so great about it. And that's why there are so many actually different chains out there. And then once we have all this, then we want to forge this block to the chain, right? So we want to actually add this to the chain. So previous hash is going to be the blockchain dot hash of the last block. Yeah. And then we also want to get the block equal to block dot new block for getting the proof and the previous hash. So this is our new block that we're adding, and then we want to actually get the response. So what is the response going to look like here? I spelled response right? Yes. So we're going to have multiple things. We're going to have the message, right, which is going to say, hey, a new block was forged over here, just to know what happened. It's like, hey, a new block was forged. It wasn't sent to this person. They were able to forge it. We're going to have the index of the block, so we know where it is. Then we're going to have all the different transactions, the proof, and the previous hash to know where it actually lies in the chain. So we can put in a message to say new block. So it's forged. We forged it. And then the actual index is going to be the block index. We also are going to have our transactions list. And that is going to be the then our proof and previous hash. So proof is going to be the block proof, very repetitive, and then previous hash is going to be the hopefully I spelled everything right. Otherwise, we're going to spend a long time debugging for nothing. And we just want to return the response. So we can JSONify the response here, and then return a 200 to indicate success. All right. So again, the recipient of this node is the address of the node identifier, so we know exactly whose it is. And basically what we're doing over here is just interacting with a lot of the methods that we already created, right? And we're essentially done over here for the most part. We have made our mining end, we have made our actual transactions, and the next step is really just to actually interact with the blockchain. Now, before we get to that, let me just make sure I can answer any questions that any of you all may have. That way we're not jumping ahead of ourselves. Will I be adding my code to GitHub? Yeah, I can absolutely add this code to GitHub. I'll clean it up a bit as well so that it's easier for you all to see. And then I will definitely add it to GitHub and share the link with you all. And then if I'm not able to add it, which I probably won't be during the stream, then you can keep an eye out on the the Global Hack Week channels in Discord, the MLH Discord, and you should be able to get it from there. All right, looks like Hi How's the Day was able to get it working. That's awesome. So honestly, I'm just gonna give it a couple more minutes and then we will actually start working with the APIs and interacting with them. And again, if anyone does have any issues, just let me know. I will do my best to debug. Not everything can be not everything can be solved over a chat, unfortunately, but I will do my best. Would I be able to go back to the message for new transactions? Uh, is that right here? The transactions slash new route for API route? Okay, perfect. Yeah, I'll just keep it here for a little bit. And again, it is essentially just saying the transaction will be added to a specific block and giving the index. Again, this is just saying that something happened, not really, again, not really visual, unfortunately. It is blockchain. Okay, we'll give it maybe 2 more minutes and then keep moving. And then in the meantime, just to reiterate, um, what we're doing here is just making the API routes for the actual chain, the different transactions, and the mining endpoint. So we're just going to be interacting with those very shortly. All right, I think that should be good. Next up, we'll actually move on to interacting with these. So we can actually try firing up the chain again. So let's do that. Actually, yeah, let's format the code first so it looks pretty. And then run the chain. Now you can see there's multiple addresses that it's running on. This is locally, this is on my network. Right now we're going to be running it locally just because we can't really do anything on the network, but we will be able to shortly. So you can see it's running now. Again, it's giving a 404 right now because we don't have anything. We can add something to the home directory just to say, hey, this is this is the home page. Please go to these and give instructions if needed. So we can make a get request first. So let's actually try doing that. So you may get requests to the mining endpoint. And we can see that we have a new block that was forged over here. And it gives us, let me actually zoom in here. Hopefully that's a lot easier to see than it was previously. But now we have our index 2 because we had our initial or our genesis block. But now we have our new block that was forged. So we have our previous hash and our proof over here specifically, then the different transactions that took place over here and the node that received it. All right, and this is the amount that we were given. So we can actually create a new transaction now if we've done the mine. Actually, let me go to the stream and make sure no one's having any issues with running it. So again, it's just Python and then blockchain.py. It is right here. So Python blockchain.py. Okay, so no one's having any issues, so that's good. Okay, next up, let's make a post request. Now the post request will have to be done using Postman just because it is difficult to make a post request on Chrome. So let's do that. Right here, we're going to go to our transactions. Post request on transactions/new. Okay, and then we're going to have our transaction structure in here. Now, yeah, it's going to be the sender, the recipient and the amount, and then we're going to, or we should get a message. So we can put this in actual body, and let's see what this should be looking like. Blockchain. We have our sender and our receiver and our amount. So it's going to look something like this. So you just copy and paste this because this is what each new transaction is going to look like. I'm going to put this in a new file. We'll just put it right here. And then we can actually set the sender and recipient and amount. So sender we can set to our current user, which is this right here. And then recipient, because we don't actually have a recipient right now, we'll just put in anything we want. So just any other address will do. Where did my VS Code go? There it is. So here, we'll just put in whatever sender we had originally. For our recipient, we can put in just any other random address. And we didn't do enough, like, obviously verification. Normally we would, but that unfortunately was not the case over here. And then we have the amount that we're actually sending, which is going to be 1 block. So we can actually just copy this over. Make sure the formatting is correct. Remove this. Okay. Copy that over to our postman. So let's paste this, and this should hopefully, ideally, everything works as expected. Send our 1 block or our 1 coin from this sender to this random recipient. All right, and let's hit send for our post request. And all right, we got a message that the transaction will be added to block 3, which is exactly what we're looking for. All right, so it looks like that is working. And again, you could use a curl request over here. That would be a little bit more difficult, but that is also possible. So we have this. We can also mine a few more blocks just to give it a few more tokens. So let's do that. Go to the mine endpoint. Again, we have our new index, and it'd be at this new block with this new proof and a new address. And there we go. We have our new block forged over here and another new block forged. All right. So this is going to be our full chain, right? We can actually see the full chain by going to the chain endpoint. And this is what we have for our chain. Now you can see it's indexed from 1. We have our previous hash 1, which is because it's our Genesis block and whatever information we set for it. But then this is where it really starts getting interesting, right? So for our second index, we have the previous hash, which was this, and then we have our proof for it. And then you can see we had 1 over here and then sent it away. Now, let's see. It looks like there are still some issues with this, but we can resolve those issues. But as of right now, we can see that this is sort of what the chain is supposed to look like, right? We have our transactions. We are able to mine new blocks, and we can actually see everything that we did over here. All right. Any questions with that so far? On what we've done, what we're seeing, what we're looking at. If you're getting a 404 not found, try going to the endpoint. As of right now, we don't have anything at the home directory, But if you go to slash chain, then you should be able to see the full chain. If you go to the directory slash mine, you'll be able to mine a coin. And if you go to the new transactions, you won't be able to post a method, or you won't be able to post anything, but that would be done through either Postman or a curl command. All right. So these are all the different blocks, right? Again, it's not very pretty in this case, but that is essentially what we were trying to go for, right? Now, normally the next step would be to actually have consensus, right? Because the chain is normally decentralized, so you want to make sure that everything reflects the same chain. Now, that was actually the issue that we ran into when you saw that I sent something, right, and then it sort of got written over by this next one. And we would have been working on consensus. That's essentially to solve that issue. And uh, there's different consensus algorithms that we can use. You can use, again, the most common consensus one is like, okay, which one has the most recent timestamp? And that's the one that we would have implemented. Unfortunately, we don't have the time to implement it. I do want to make sure that everyone here has at least this base to go off of, so that they have, something to show that, hey, you created your first blockchain, you were able to mine basically your own currency. You can call it whatever currency you want, MLH coin, um, your username coin, whatever you want it to be, right? And then you're actually able to do all that. All right. So that consensus algorithm would also help make it easier if you have other people joining from a different server or a different domain. So for example, over here, let me, where is it? So if you have other people on your network, right, over here, this 192, this right here is a network address. So what happens at this network address is I can access this. If I'm on the same Wi-Fi on my phone, I can actually access this and go to the mine endpoint from my phone. So if I tried to, let's say, copy and paste up until like here, and I have my phone right here, I'm just going to pull that up on here. You can see that I'm getting a not found. I don't know if that's visible at all. Let me actually make sure it is. Okay, you can see that I'm getting a not found if this thing works. You can also see that it's trying to do some facial recognition. But if I go to like let's say mining endpoint on my phone, slash mine, then you can see that a new block was actually mined on my phone. And it was at index 7 as well. So you can see that index 6 was on here, um, on my screen. And then right after that, I mined it on my phone and I was able to get index 7. So this is essentially the idea of like a network, right? You have one network that all these different nodes or these different people are connected to, and then they're all mining and they're all trying to get it. They're all trying to verify their transactions as quickly as possible. So the way the consensus is supposed to work is if one person, let's say if on my phone I had a different chain from what was on my laptop, then I would need a sort of algorithm to say, okay, which one of these is going to be the correct one? Is it the longest one? Is it the one that has more blocks that have been forged? That way we know that, hey, maybe this person was able to mine more more crypto, basically, or are we doing the one with the timestamps? How are we going to make it work? So that's essentially what the consensus algorithm would do. But in this case, you can see that even if we're on a network, this gives a pretty good example or a pretty good idea of how a blockchain is supposed to be distributed, how it's supposed to be decentralized, and how all these individual nodes sort of work together in this network to verify that the other network is doing everything correctly and that theirs is doing what they expect it to do. All right. And yes, you can absolutely see the code one last time. I will pull that up. And if anyone else has any other questions, Do let me know. Is there a specific part of the code that you want to see? Uh, Priscilla? Let me quit out of this, clear this out. Yeah, you're welcome, absolutely. And again, if you haven't already, do make sure you check in to the event. I will send the link one more time. There you go. All right, it worked. Awesome. Hi, how's the day? Got it working. That is great. Yeah, definitely do the Postman part. You don't have to actually mine it through Postman. You can mine it on your like when you open it up as well. So if you open this up and then get this specific server right here. So it starts up a server. You can actually open this up. So I just command clicked because I'm on a Mac. You can control click if you're on Windows, and then this will open up a web page. That web page will take you to a sort of a not found page, right? Initially, but you need to go to the search bar over here and actually type in forward slash mine, M-I-N-E, hit enter, and then it will actually mine that new block for you. So you can see that this mined a new block for me over here, and now it's at index 2. And I can just keep doing that and mine more and more and more blocks. And now we have 25 blocks. And then if I go to the endpoint chain, then we can see the chain of all the different blocks that we just mined. All right. And close out of these. So again, just sending the get method and to the mine and the chaining over here. Thank you for joining. I appreciate you all being here. Uh, so hi, how's the day? Said, what does the postman part do? The postman is for post methods, right? So it's difficult to actually write post methods uh, in the browser itself. So Postman is an easy way to interact with that. Essentially, it's just interacting with the API. We could call get methods from there as well. I just did it from the browser because it's more accessible to everybody else who may not have Postman. But specifically for the post method over here, where we're actually um, going to the new transactions, right? We're actually creating new transactions where essentially you have somebody sending money or sending, let's say you wanted to send a few Bitcoin to your friend, right? You need a sort of method to have those transactions actually take place, and that's what this is taking care of. So for our, let's say, MLH coin, right, we have um, we're trying to send the 1 or 2 MLH coin that we mined to a different person, and that's sort of what's going on over here, right? We're able to send our, let's say, 500 MLH coin to from me to a different person, then it'll show up in their wallet. So it'll show up as them owning it. All right. That is essentially what the Postman part does. Thank you so much. I appreciate that. I'm glad you learned a lot, right? That was the goal. Hopefully, all of you understand the blockchain a bit more. It's been a little, it's been demystified a little bit. I know when I first got into it, it was very confusing, and I had no clue what was going on. But yeah, now that now that I understand, I was like, all right, let me have a stream. Hopefully, everybody else will be able to understand as well how cryptocurrencies work, how NFTs work, how all of that great stuff works. So I'm glad you all are, able to learn. Did I go to Pesh? Yes, I did go to Pesh, actually. That's hilarious. um, hi, how's the day? Thank you so much. All right, that is about it for the stream. And again, I will be uploading the code. Keep an eye out for the GitHub in the Discord. All right. I'll be sending it all over there after I actually push all the changes, and I'll add the consensus part as well. So if you want to take a look at that, you can. and I'll add much more detailed comments and try and make this a lot cleaner so that it's more accessible to all of you. And I'll also make sure to include the main.py, this little part that we worked with, as well as the example block, because why not? All right. And then if you have any other questions, again, feel free to reach out to me. But unfortunately, my time is about to end, right? So I will be dropping out. Again, thank you all so much for being here. And hopefully, I will see you all at my next stream, which is in 2 hours. So if you want to be there, definitely show up. That's just an introduction to Python. If you all did this, I don't know if you all need an intro to Python, right? You all are experts already. But again, if you want, do join, and hopefully I'll see you all there. All right. Bye, y'all.